Welcome to qnawire.
In this question, it is about a carnival ride. Okay, so the ride rotates in a horizontal circle, and so we need to find out the speed at which the platform begins to roll upwards, and the normal force experienced by an 80 kg rider at this speed. Okay, so this is a circular motion problem. Okay, so we need to first draw the free body diagram of the platform, or or the of the platform. Okay. Okay, so this is a platform. Okay, it has a weight mg, and then you have a normal force pointing like this, and the angle here is 70 degrees. The centripetal acceleration is to the right. Okay, and this angle is 20 degrees. Okay, right. So another thing we also need to find out is the radius of the circle. Okay, so from the diagram, you see that there are two horizontal distance we need to consider. So one is 5 meters. Okay, the other one is this part. Okay, this is 1.5 cosine 70 degrees. Okay, 5 plus 1.5 cosine 70 degrees. This is 5.51 meters. Okay, and then from the free body diagram, okay, using Newton's second law, okay, summation of forces along the x gives us MAC. Okay, so we have n cosine 20 degrees equals to mv squared over r, and then summation of forces along the y is equal to 0. This gives us n sine 20 degrees equals to mg. Okay, so what we can do is 2 divided by 1. Okay, then we get tangent 20 degrees equals to gr over v squared. Okay, so actually v naught, yeah. Okay, so v naught square is gr divided by tangent 20 degrees. V naught is gr divided by tangent 20 degrees square root. Okay, so 9.81, radius is 5.51, divided by tangent 20 degrees, you get 12.2 meters per second. Okay, then part B, what's the normal force? Okay, so if you look back on our equation, okay, you can see that we can use it from equation 2. Okay, n equals to mg divided by sine 20 degrees, okay, equals to 80 times 9.81 divided by sine 20 degrees. Okay, you do this calculation, you get 2290 newtons. Okay, so this is the answer for part B, and that's all for this question.